Hello, my name is Ed Sherman. This is course AIT381, Emerging Broadband Technologies, offered in late spring 2015, and this movie clip is about IPTV network architecture. IP. IP is an internet protocol which provides a set of functions for different applications and computers to communicate. IP applications could be email, web browsing, and video streaming. Computers could be mainframes, PCs, Macs, and now new devices are being equipped with IP, such as IP set-top boxes, televisions, refrigerators, thermostats, and other smart home products. It's basically a common international language that allows devices to communicate over the internet. IP is also connectionless oriented, which means that packets are broken up and can take any path to get to the destination, but delivery and the quality of that delivery is not guaranteed. IPTV uses the IP standards just discussed to deliver digital audio and video to consumer devices and allows consumers to perform command and control functions, select content, and be interactive in a bidirectional method with the content provider. Several key factors that make up the IP network are the IP addresses and the IP packets that go across the network. So let's first cover IP addresses. An IP address can basically be thought of as a telephone number. So when a consumer with a regular telephone number dials someone's number, they expect the other end to pick up and respond. The same thing goes for IP networking. But in IP networking, there's no telephone numbers, there are IP addresses. So an IP address, when a user wants to connect to a destination website, they have to know that destination website's IP address and or name, and then it gets converted via DNS to an IP address. But that's not going to get covered here. We're just going to discuss IP addresses. So the IP address is a 32-bit dotted decimal format separated by periods. So basically it is 8-bit octets, and there's 4 of them, and that's what makes up the 32-bit dotted decimal format. That's for IPv4 addressing structure. For IP packet, that's a single message unit sent over IP. There are elements that make up the IP packet, and those elements include source and destination IP addresses, the length of packets in bytes, the header checksum, and that's used for error checking mechanism. There's a type of service, and the type of service is a group of bits that can be used to differentiate different service types and importance of one versus the other. Time to live, and that is a counter that is decremented each time a packet is forwarded in an IP network. When the value hits 0, the packet is destroyed. And what this does, this prevents endless loops from running around the network. Then there's fragmentation control, and these are bits used when a packet needs to be split up to travel across a specific network segment. Each one of the elements included and discussed here, it takes up a certain number of bits inside the IP header, which is a 20-byte header. So each one has a certain number of bits allocated to them that eat into that 20-byte IP header. Now we're going to take a look at the system architecture of an IPTV system. And in this, you could see we'll start from the left hand of the network and work our way into the user's home, and we're going to explore each section of the architecture in more detail in some of the coming slides. But we'll start with typical IPTV system architecture, and this is composed of, you can think of them as 4 sections. So starting from the left and working our way to the right, we have the content head end. And that's basically the super head end is what aggregates all the information coming into it from towers or satellites, and aggregates that and then sends it over the core network, which is a metro wide area network, which is generally a fiber network. And that WAN with the various video hub offices that are there connects to the access network, where you have the video central offices and network access systems, and that eventually makes its way and feeds into the customer's home, where we get our video signals and watch our televisions. So that's a high-level view of an IPTV system network, and we're going to take a look at each individual function in more detail. As mentioned in the previous architecture slide, the content, the head end, is where the content is received. It's source for much of the video content within the system. It's the heart of the IPTV system. It's basically considered as the central point within the network. The head end, the super head end, is where the broadcast programming and on-demand content is captured or ingested into the system. Equipment is based on PC server and IP networking platforms, and can consist of the following: billing systems, application servers, video on demand VOD servers, gigabit switches, gateways, load balancers, a lot of the stuff that other than VOD, but a lot of equipment that you would find in an IP network. Then you have DRM license servers, content reception and signal conditioning systems. All these mentioned make up the content head end part of the system network. So from the content head end part of the system architecture, we reach the core network piece. Now the core network is fiber backbone wide area network, and video hub offices. That's what makes up the WAN. There's a fiber network, and then there's the video hub offices piece, and that's what the core network is at a high level. That's what the core network is. The core network is responsible for transporting all of the system's content. That can be video, music, data, and channel lineups. This is considered the backbone of the IPTV system. Local content and advertisements can also be inserted for the particular region this backbone is covering. That's where the video hub offices come into play. Bandwidth is a major concern in the core network. There must be enough bandwidth for all the network traffic, data, and video between the various service areas and the head end. If there's not enough bandwidth, then we're going to have a lot of unhappy customers, and we won't be able to deliver the content that we need. The core network must be scalable to accommodate customer growth and content growth, and it transports data from the head end to the access network, and the bandwidth management piece that we just discussed. That's a critical piece when planning and designing your fiber WANs and the links and the equipment that ties together in the core network. So from the core network, we're going to move a little closer to the customer's home with the access network. So with the access network, the two we'll cover is telco and cable access, but there is others like satellite, for example, Dish, DirecTV, companies like that, that involves having a dish mounted on the home to communicate with space satellite. But we're not going to cover that. We'll just cover telco access and cable access. So with telco access, people you may have heard as last mile. That's commonly known as last mile with telco operators that connect the last piece of the network to the customer's home or prem, as it's often called. So that's the last mile reference. Telco access uses DSL and fiber to the home FTTH to deliver IPTV and broadband services to the customer's home. Carriers such as AT&T and Verizon provide the service. Depending on what region you live in, will depend who your last mile provider is. Cable access, on the other hand, is a bit different. So with cable access, you have some national and regional players such as Comcast and Cablevision. It also depends what region you live in to see who your cable operator is. Cable access uses QAM and QPSK RF signals over coax cable. QAM is quadrature amplitude modulation, which is RF modulated signals over coax cable, and this is used on the downstream channel from the core network to the customer's home. The QPSK RF modulated signal is quadrature phase shift keying is what it stands for, and that is a modulated signal for the upstream return channel, and that's back to the core network. So one is from the core network to the customer, and the other is from the customer back to the core. Cable access also uses DOCSIS technology, so that is data over cable service interface specification, and that's technology that allows cable operators to deploy broadband services over their coax network. With DOCSIS, part of the cable network becomes an IP network that supports IP video streaming and video downloading. So now we reach the customer's home, and the home network is basically a network of its own. It's gotten a lot more complicated in recent years with a lot of new IP-enabled devices in customers' home. But we'll start with the residential gateway. So the residential gateway is it's a combination of a broadband modem and the cable router. So generally, one of these service providers that we discussed in the previous slide, the access slide, will give you one of these boxes to install in your home, or a technician will come and install it generally for you. That's considered a residential gateway. Then we have IPTV set-top box. We have Wi-Fi router, computers, and other IP-enabled devices like television sets. Then we have what is the physical layer, and like I referred to earlier, that's where we will have a bunch of different devices that could be communicating over this physical layer, right? So if we have thermostats in the house, or that IP-enabled TV that has maybe Wi-Fi already built into it, gaming console, whatever you can think of these days is becoming wireless enabled, and that would be the physical layer to distribute the content throughout the home. And those physical layers, could be wireless, with a Wi-Fi router in place, or could be Cat5 Ethernet, coax, phone line, or power line can be used. I was at a friend's house, and he has a fairly new home, and one of the options that he got when they built the house was to have every room with Cat5 terminations. So he has RJ45 jacks all over his house. So really neat feature to basically have a connected home network. Although broadcast television remains a part of video operator services, to stay competitive, operators deployed IP networks to support IPTV. IPTV services provide both multicast and unicast services using a switched digital video architecture that switches and routes video data from the source to the destination. This enables the operators to improve efficiency of their network while allowing for interactive communication between the end user and the content provider. References to this movie clip came from two textbooks, IPTV Crash Course by Joseph Weber and Tom Newberry, and Video over IP by Wes Simpson. Thank you. Hope you enjoyed the movie clip.